Good evening, everyone. A very warm welcome to all of the aspiring engineers and tech enthusiasts joining us today. I'm Sithili Vijayasekar, and I'm honored to be with your host in this evening. Today marks us a very special milestone as we kick off workshop of the first committee, a dedicated software engineering workshop series organized by the Sasnaka Sansada Foundation and the Nipil Mani team. This series is designed to bridge the gap between the academic and the learning rapidly evolving tech industry. So, uh, while many of us are used to systemic being the start of the respiratory, tonight it's the start of the journey into the modern software engineering mind. So, our session today is titled Computational Thinking in the Age of the Vibe Coding. In an era while AI and high level abstractions are changing how we build software, understanding the core logic behind the code is more very important than ever. So, to lead this first workshop, we are incredibly fortunate to have someone who truly understands the journey from the very beginning as a student to becoming an industry leader. So, I warmly welcome Mr. Suhasana Dhamsika, who is the Senior Software Engineer at Q4US Technologies. He also holds a BSc in Computer Science from University of Colombo School of School Computing. Most importantly, he is an alumnus of Sasnaka Sansada. Mr. Suhasana, it's a privilege to have you with us. The floor is yours.
Thank you very much, and good evening to all of you. I hope all of you guys can hear me, right?
Yes, Mr. Suhasana.
Okay. So, I am Suhasana Dhammitu. I am currently working at Q4S Technologies as a senior software engineer, and I am a student of University of Colombo School of Computing, and a member of Sasna Sansad as well. So, yeah. So today's session about the computational thinking in an era of vibe code. So most of you guys, I think, familiar with vibe coding now because I heard all of you guys are tech enthusiasts and have a passion on computer programming. So let's start the session now. I can share my screen. Can anyone? Oh, okay, now it's is my screen visible?
Yes, Mr. Suhasana. You can see the screen.
Okay, we then start. Today's topic is computational thinking in age of vibe code. How AI is changing problem solving in software engineering. So, actually, software engineering means problem solving. Actually, so when it's come to the software, people face many problems before the software is built. So, to solve most of the problems, engineers made software. That what we know so far. So today's overview is today we are going to talk about what is computational thinking and what is vibe coding and risk and opportunities of both of these and AI mistakes and debugging and also prompt engineering as a computational thinking skills. Why this topic is matters? So in today, AI coding tools are now mainstream. We all use AI for any task that we are currently work on our day-to-day activities, especially programmers. So now we can implement a website within 1 hour using these AI tools. Earlier, it takes around 2 to 3 weeks to make a website and deploy it to the web and use it. Now it can be done in 1 hour using these AI tools. And as a student can generate full projects instance. When I was in university, the AI is not familiar so much. So we have to implement full project. Even in a 6-month project, we implemented a web application to handle a restaurant orders. So now we can do that in 1 to 2 weeks using this one. From that, we can identify the speed is increased and understanding, but some of the understanding often decrease because of these AI tools. It is too easy to copy and paste the code and run as an application. And currently in the industry, uh, because of these AI tools, expecting engineers, not a prompt typist. Earlier, if you have a skill to code, if you can, let's say, reverse array or uh, find obligates in array, that kind of a code you can write it. You can easily get a job in software industry in earlier, but now you can do that. You have to have a excruciating idea about basic knowledge about the computers and other technical things. That's what expecting current software engineering industry. And also competitive advantage is ability to think and validate, because nowadays even school students are able to build softwares using these things. So as a software engineering students, we have to compete with those ability to think and validate our code and applications. So let's talk about what is computational thinking. Computational thinking is a structured way of thinking of understanding a problem clearly and break it into manageable parts, design a logical solution, and express it in a way a machine can follow. That means if you are thinking as a computational, you have to identify the problem first, as it is a problem. Uh, let's say you have a problem, you can't find the performance of your vehicle, and you have to find it once a month, and you can easily forget where the service, when the service happened, all kind of stuff of your vehicle. So first identify the problem and clearly break down into the manageable parts. So we have to break down that big problem to small parts to identify what can we build as a software. I'm talking about software. It can be applied on any engineering structure, but today I'm talking about the softwares. And those breakdown manageable parts, we have to design a logical solution to implement that on. And after that, we have to express that, because we are working on a computer that is a machine. So we have to provide instruction to express that logical solution to machine can understand. So it's not about the programming language skill. Now programming language is a very common thing. it is uh, available in many sources in the YouTube or any courses, then we can follow. It's not about the programming skill, programming language skill. It's about the way we think to structure the problem. So earlier, before we coding, we have to think about what is the real problem and who are the users that this software is going to use. Because if the users can use it properly, there is no point of building that one. And what are the constraints to use to implement this one? And finally, what is the system do as a whole program? And a computational thinking gives the ability to analyze problem logically rather than guessing. That means we can start a project by small idea, but going along, we have to come up with a logical solution to identify the problems that we are going to solve. So rather than guessing, it is very good practice to have a logically solve your big problem and manage to break it down to the small parts. That is the basically computational thinking in software engineering. So let's discuss the element of computational thinking. Uh, these are there are some other definition of these elements, but I take the common element that we are using currently. That is decomposition. That means breaking down the big problem into the small uh, problems, and pattern recognition, and abstraction, algorithm design, and test and debugging. We can discuss all of these going along. So first, we discuss the decomposition. Decomposition means we have a big problem to solve as software engineers. We have to break down that large problem into the smaller subproblem. Uh, let's get an example like a food delivery app. So when it's come to food delivery app, the most common example is Uber Eats. So you have a user registration and login, and restaurant search, and menu and cart, food search, payment processing, delivery tracking, and as admin there is admin board. Those kind of a small problem are scope into one single circle. That is our last problem. So our job is to identify what are the smaller sub problem that large problem have. So that is the main idea about decomposition. And the other element is pattern recognition in software engineering. Many problems repeat across systems. That means in any kind of engineering field, there can be some problem some people already solved. So we can use it as it is. We don't need to solve it again because it's already solved. So we can use it for our system to uh, gather more uh, reliable source as a solution. So our job is to identify in our sub problems. First, we have to get the big problem and we divide it into sub problems, and we find if there is any patterns uh, that we can use to implement our program as a library. Let's say if some people work with PDF generation library, or uh, let's say uh, authentication library, we can identify if that component is in our system, we need to use that. So we can get that one from there and we can integrate to our system. So that is what basically pattern recognition means. So we have to identify what are the components that we can use as a pattern. So common patterns are the CRUD application. So CRUD is very common in use, and authentication and authorization. It is also available. Pagination, sorting, filtering, that kind of stuff is already available. Plans of architecture, and especially validations if we are building on a common method application. Let's say a restaurant application or food delivery or library management, any kind of application. So these common parts is need in any kind of application that built so far. Okay, moving to the next slide. The other one is abstraction. So main rule of a software engineering is show show what the user want to see. We can use lot of things behind the back, but user doesn't care about at all. If I am a user, I like to use less kind of uh, components that I work for because it is so easy to use. So our job is to uh, identify those things and show uh, only the user needs. That's called abstraction in software engineering. Let's say, uh, as an example, we can get a car driving and engine design. So we have to uh, build the engine to drive a car, but user only knows how to drive a car. User don't need to know about the engine or brakes or any kind of stuff. User just need to know uh, the instruction of how to driving the car. So in software engineering, to achieve that, we are used interfaces, APIs, and modules. We use that to hide implementation details, uh, and we can also build reusable component using this to use another application. So when it comes to the AI, if you prompt this one in a, let's say, ChatGPT or Gemini, it not providing us as a reusable component. It just gives as a component without any interfaces, or it can be implemented as a modules. But when we are integrating those things, we have to cautious about this abstraction method for future integration that the software needs. And finally, uh, the algorithmic thinking. This is the crucial part of the application. Algorithmic thinking is step-by-step solution planning. So we have now big problem, break into the smaller problems, and we identify what are the patterns that use, and we identify what are the things that user needs to see. And now it's time to implement the application. Now in here we have to define input and outputs, identify constraints, what are the logical rules that apply to the application, plan the steps. Don't start code immediately. First, you have to design the pseudocode, how it's going to be, and consider the edge cases like what are the what will happen. The user is cancel the subscription, that kind of stuff, and importantly, analyzing efficiency because user needs to work on application in a very efficient way because time is very valuable for a user. So those are the things that we identify as a computational thinking in software engineering. So this is the old method that we are worked on in software industry before the AI. These all elements are done by humans and implemented by human, and it takes a lot of time to identify these components. Yeah, that is the computational thinking. Do you guys have any question regarding those things? You can ask. Any question, anyone? Okay, so silent means there is no question, right? So let's move on to the next slide. What is vibe coding? So now we are coming to the fun part. Vibe coding is building software by intuition and AI assistance. So before we have to think about everything, the syntaxes and coding methods, uh, classes, objects, everything we have to think about all of this early. But now, the era of vibe coding, we don't have to think about all of these things. We just can write a prompt and get the code by the AI. So that is what basically vibe coding means. We can build software by intuition. That means we are telling AI what we want and it gives us what we want. So typical workflow of a vibe coding is we start in with the prompt and we generate the code and we run the code, and obviously we face some issues and we again run the prompt and fix it, and we again repeat whole process. So that what basically workflow of the vibe code. On that one, we have some strength on rapid prototyping because we are always thinking about the high level structure. We are just prompting it, and the prototype is actually good and it is well documented in the AI chatbot. And the weakness is we can skip planning and understanding because it gives us everything we think before in the AI. So its weakness is can skip the planning and understanding, and we are as a human we are too lazy to read that code, and we just use it as it is. So the difference between traditional engineering versus vibe workflow. The traditional workflow is based on requirements, and we design the application and we code it and we test it like a manual testing, or we write automation scripts in this industry and we deploy the system. So that's what in the traditional workflow does. So in the vibe coding, we prompt it out and we generate the code and we run it and we fix some bugs of that and we repeat the whole process until we get a stable application to deploy. So in the traditional workflow, there are a lot of work to do by human, but in the vibe coding workflow, much less work to do as a human. So that's why it is very popular because I saw in YouTube today, one person is building a startup using this vibe coding method. He started uh, building an application, the mobile application for around 50 to 100 user base application. Now he's building a startup that makes 1 to 3 million US dollars per year for that application. So that is the advantage of this vibe coding because it is very less timing and less thinking and work with easy. So as a software engineering students, we have to uh, integrate these things to our day-to-day activities, but not losing the computational thinking with that computational thinking. So the big difference of these two strategies, planning and validation. So in the vibe coding, there are no uh, stable way to validate this code. We are just reading out and we are running it, and any other time it can be broken. So as an example, in the last 2 months back, there is a layoff on a AWS Amazon company because of this AI integration, and they face a huge bug on their, I can't remember exactly what is the application, and because of that they are lose lot of money because of that bug, because they are not validating their solution before as a human. So why love? Why student love vibe coding is fast result. It gives very fast result. We don't need to have spend hours of hours reading documentation, reading Stack Overflow, any kind of stuff. We just can get the expected output very fast. And it helps beginners to start projects quickly. Now, if you have a brief idea about any problem, you can just start it using a simple prompt, and it is actually good for a software engineering student, because in the coming era of software engineering, it's all about thinking and thinking. It is the main component of your software engineering career, because if people can think, uh, that is what future gonna happen, because all of the structured work, that means coding, automation, testing, those kind of stuff are going to be replaced by AI in soon. That is the reality of this software engineering industry. So our job is to uh, motivate and our to train our brains to think in very different way to find out the solutions. And also it is reduces repetitive coding tasks, because once we are generating the code, we can use it in anywhere as a whole component. But when it's come to reusable components, there we have to implement as a component, but we can just copy the code and paste it anywhere. The code base is going to be very long, but it can used repetitively, and we can get instance explanation and example using this AI. In my company, we actually created a whole user manual for a system, about 40 pages, using anti-gravity IDE. I think all of you know anti-gravity IDE. If you don't know, search it out. It is an IDE that made by Google. It can use as a coding AI chatbot along with our code base. So I created a user manual using the whole repository and 40-page long PDF in very detail about the application, and it is very good because I done it in one day using these AI tools, and it's quite good because it has everything about that software. What are the examples and how we are going to do that, and what are the explanation of the logic? Everything is there, and if we are doing it manually, it takes months to write that kind of a documentation. So these kind of stuff very useful when it's come to the these kind of stuff, and it feels like highly motivated intern because AI doesn't get tired. We can ask as much we want, we can get a better result. But there is a risk of using AI as a student. When it's come to the industry, using AI is a privilege because uh, the implementation time is very less. We can use as a tool to write our code and implemented it very easily with less time. But as a student, we have to learn about how the basic things happen and how do we improve ourselves to go into the software industry. So the common problem is when we are using the AI, student cannot explain their own code because they are just prompting it out and take it and copy paste it, and they can't explain their own code. And if they can't explain their own code, surely they can't do any debugging on that one because it is a nightmare to debug of not understanding a code. And also not edge case thinking, because as a software engineer, we have to think about all the possible paths that software leads. Let's say uh, there is a uh, form and it has a input field to upload an image. So we have to think about what will happen if a user upload a ESC file for that. So we have to validate all of things in our code. But in the AI side, they are not thinking about that one. They are just keeping track on our prompt. We don't ask about that kind of a validation in a prompt. So it's gave the very high level implementation of that one. So that part missing in now vibe coding here. And also there is no test driven mindset. We are just implemented it, we are running it, and if it work, we are deploying it. But there can be some scenarios our whole system can break. Uh, so we have to identify those things using that computational thinking, because we have to think about all possible ways to break that software before we deploying it. Because after we deploying it, if the software is break, that is losing of money. That is a bad thing to happen. And also there are no complexity awareness of the code. That is the main issue of the uh, current student have, because in the interview sometimes they can't even identify uh, in the double for loop what is the time complexity of that one also. So that is a main risk in this AI using as a student. And also AI output is always not a correct output. We have to validate those things uh, to use in our softwares. AI can invent APIs that doesn't exist. It can happen. It always happens because when we are using ChatGPT to implement something, and if we get a one thing wrong in a prompt, it's going to be a very hallucinating form and gives us very incorrect solution for our system. So that is what AI is, because he is trained to give answers related to our prompt, and if that prompt is go out track, the solution is always going to be out track. And it also generate insecure codes. uh, it can happen because AI is not perfect enough to use to trust as a human for now. It can be done in the future, but now it cannot be done yet. And it can miss some requirements also, and it can give wrong logics, and it always give a lack of reusability because it just provide us the component we can use, but it not thinking about the reusability of that code again and again. So let's get an example If we are building a PHP application, let's say we are input this prompt, build a PHP login system. AI might generate a plain sequence. Let's say the create query without any injections. So without any injection, it is what very unsecure to use that kind of SQL query, because anyone can update in along the way, and no prepared statements. That means when it's come to the generating login systems, any kind of a system, it not actually prepare for a statement, the workflow. Let's say we are working on a login system, we have to get the username and passwords, and we have to check with the our hash codes, and if there are any wrong password input, we have to validate those things. Those kind of a prepared statements are not available that using this basic prompt. We have to tell the AI what is the workflow that going to be using in a login system, and it also gives us the weak password storage, because we are not telling us what kind of a validation we want. So it is gives the basic needs of our prompt. So as a use of AI, our job is to use our thinking to improve our prompt, and we have to review our code. Uh, if it's like it's a junior developer's code, because we have to thoroughly review the AI generated code, because it can be lead into some known issues. So that what computational thinking wants to us, to identify what that code happen is to, what are the issues that can be faced, and what are the improvement that we can add to this code, generated code. So keep in mind, we have to treat this AI generated code as a very low level code, because we have to review it very thoroughly. So to do that, we have to improve our computational thinking and also the reading skills. We have to read the code and understand that. To get such kind of ability, we have to code it in our hand, not using an AI. So another example is this is actually a common example to what AI hallucinates about. Uh, when it's come to the optimization problems, let's say find duplicates in an array, or working with a salesman problem, or work with the subset sum algorithms, or cutting stock algorithm, any kind of NP-hard problems. NP-hards means it that kind of a problem don't have any structured way to implement a solution. There is a solution, but we have to get a lot of computation power to get that optimal solution. So to achieve a solution for that kind of problems, uh, we have to find a greedy way, because if we find a one better solution, we stop the finding the solution, and we satisfy with the uh, found answer. So when we using AI to solve that kind of a problem, I tried this one in very different way, because I work with an optimization problem for a client. It get worse to worse, because it doesn't understand the a lot of combination and validate those combinations, and how to address multiple paths to solve this kind of optimization problems. So most of the time it gives a very unoptimized code using O and square, a big O, nested loops, and uh, let's say O and uh, third square. That's kind of a very unoptimized code. It gives like that. So we have to have a very good idea about what is optimization in our code, what is the big O, and what is the time that takes to run this application, and how do we improve that application to run fast, and how to use uh, every available computation power in our computer. Those things are not provided by the AI. We have to think about our own. So that what comes into computational thinking uh, for this one, because if we are unable to solve that kind of a problem, there are no point of use of an unoptimized, inefficient software. So user doesn't like to use that one. So why CT? CT means the computational thinking is more important now. Now in today's era, the coding is very cheap. In last 2 to 3 years back, the coding is very expensive because coding is done by humans, and it takes a lot of time to educate, learning the syntax. We have to remember the syntax, and we have to find the keywords, and we have to implement the classes, objects, and all kind of transforms. Everything we have to build ourselves. But as this AI is integrating now, it is very cheap and very easy. So it is actually no value for learning just code. That is not a skill in current software engineering industry. So as a student, you guys have to focus on how to think uh, as an actual engineer, because in past years, as I said before, if you can code, you can hire any company and get a higher paying job. But now it can't. Now even postgraduate software engineers also struggle to find a job because of this stuff. To achieve that kind of a competition, you have to uh, improve yourself on problem frame. Framing means you have to scope your problem. Uh, what is the use of the problem? What are the users of that problem? Who are the users of that problem? And what are the out scope of that problem? And what we can implement so far for now? That kind of a framing, you have to have a clear idea about how to uh, frame your problems and ideas, and you have to ensure the correctness of your program, because if the program is given a wrong output, it is always uh, wrong with the developer, because we have to validate all the things that are done by software. And also we have to focus on system design, because now everyone can code. The most crucial part is the design in the software. Not all the people can design the software properly. So that is a skill all students have to have, because if you can design a system in within a subcomponent, let's say, uh, it is you have uh, more chance to getting hired in 2026 because of that skill, because that what software engineering expect now. And also we have to focus on trade-offs, because what we can't is can't, what we can is can. So we have to give up what we can't do, and we can adapt what we can do. From this AI, the lot of things can be done because of it taking less time to implement anything. And also, uh, crucially, we have to think about validation and testing, because nowadays validation is a crucial part, because the data, and especially the data, is not secure, because everything is available on anywhere. Because we are using ChatGPT, uh, Gemini, even the mobile phones are using our microphone access to get the data that we talked. Uh, so now we are living in that kind of a era. So everything is available for anyone. So we have to validate the data, logics, and we have to test it properly. So that what computational thinking does in this new generation of vibe code. So let's talk about the prompt engineering with the modern computational skills. Actually, the prompt are requirement documents. It is very good to have that kind of a detailed prompt, because uh, earlier we have to document the all the requirement in a one place, and we discuss with uh, teams about the requirement. We take like 2 to 3 weeks to discuss about the requirements now, and it's sometimes it's not documented as well enough. We are just document the main idea, and we are working on that one. As a developer, we have to figure out what is this requirement does, and we have to ask about the business analysis about this requirement again and again. It is a nightmare to work with. But when it comes to the prompting, we use when we use a better prompting with the explanation, and uh, divide into the subcategories, and it is a very good documentation that we can refer after the uh, software is developed. Because if some wrong logic is happen, let's say there is a massive bug, we can't find out where, we can read the whole prompt history and take that as a documentation, and we can figure out what can be wrong in that logic part. From that we can easily identify what are the things going to be wrong. So to do that, we have to have this computational thinking in our mind to provide that kind of a prompt into AI. So for that kind of a prompt, we have to use objective, what we want, and what are the inputs and outputs. And also we have to say what are the constraints, because let's say we getting a restaurant app, so we have to uh, think about the objective. Objective is taking the orders, and preparing the orders, and deliver the food, and we have to track on the inventory, and we have to track on the delivery, and we have to track on the users. Those kind of things are objectives. So input output means users provide the detail of what they order, and output is what is the order gonna be like, and what are the order tracking details. Those are the outputs. That kind of stuff we have to add that to the prompt. And also the constraint is a very crucial part, because when we are developing a software, we have to frame into the constraints because we have to achieve the security of that users and we have to improve the performance based on this. So we have to use those details to the prompt as well. And when it's come to the good prompting, it always good to have assumptions and ask the pseudocode first because we can check if the logic is correct and this can be done in a more suitable way. So that is the main advantage of using this one because if we are having a pseudocode first, uh, we can identify easily what can be wrong in future. So for that we can be prepared when it's come to the implementation of the software. And also we can ask for the test cases. So from that we can validate our software and test thoroughly from using this AI tools also. So now you can see that to do all of these things, we have to have some kind of a computational thinking our own. So that what now the industry is expecting to do. Okay. So as example for a bad prompt versus good prompt, let's say make me a login system that is a very uh, big scope prompt because AI doesn't understand what is the scope, what are the constraints, what are the logic that we have to use, what are the hashing mechanism want to use. It doesn't give any explanation about these things. So the AI can give a much unoptimized answer for that kind of a prompt. Let's say we are providing a prompt like build a secure JW token API with a bcrypt with Postgres database and with the rate limiting for the API calling and the test cases for that API. So from that, AI knows what are the constraints, what are the output, what are the hashing mechanism, what is the database, what is the rating limitation in the API side, the HTTP calling. Those kind of detail is available for the AI. So AI now can implement a better solution for us. So to get that kind of an answer, we have to use our thinking in this prompt. So the lesson is structured prompt is structured thinking. We have to think step by step to get that a proper solution step by step. Okay, how to use AI without losing computational thinking. So as a student, I know you guys are in a very tricky situation. Uh, how to get a job, how to improve ourselves. As a suggestion, this is my opinion. You have to code your own without any help of AI, and also you have to work with AI to how to verify our work and find out the new technologies or new way to implement things. As a student, you have to work on both sides in the same time because from that you can improve your computational thinking and be a better software engineer in the future. So to use AI without using computational thinking, you can use AI to uh, find a solution for a big idea. So let's say you have an idea, but you don't know how to implement it. So you can use AI tools to get a brief idea about that problem and get a step by step explanation of each possible solution. So it is very good to use AI for that kind of stuff because it is improving our thinking aspect and also our logical side of the thinking. And also we can ask for the pseudocodes, because from that we can improve our coding uh, abilities, because we are getting a pseudocode. Pseudocode have the instruction of what we are going to do in the code, and we can use that pseudocode to implement different way uh, in the code part. Because if the pseudocode is there, we can implement that pseudocode instruction in very different way. We can implement multiple solution for that pseudocode as well. So we can find out what is the best solution, what is the most efficient one, what is the most easy one to write. So that kind of stuff you can compare yourself with uh, that coding task. So that is a very good practice to have as a student in software engineering. And also you can use this AI to refactor your code. Let's say you are writing an algorithm. Let's say you are doing an assignment. So you write your code and you run it, uh, and it gives the expected out. But we doesn't know that code is well written and optimized enough. So we can use AI to check that our code is good enough, our code is efficient, is our code is more can be more improved, or getting more idea about uh, solving that particular problem in different way. That kind of idea you can get from the AI as well, and that is also a very good practice as a student, as a software engineer currently work on. Even now I am also using that one, because it gives us very good answers to think about different solution for same problem, and also generate test case. From this we can identify most of the bug in your code without even realizing it, because when we are writing it we can't identify those bugs in the code. We are just writing, we are just checking on the happy path. We are not going thoroughly enough for the all the possible path that code can go. So generating test cases using AI, it can be done from AI. So it is when we are using a good prompt to use every possible way to use that code, it gives us very good test cases to use on our code, and we can verify our code is good enough to use in software. And also using this AI, we can get a very good documentation, step by step, very detailed, very explanation. So that is a main advantage of using these AI tools in this kind of a situation. So think, always do verify your code, debug your code, and test your code before uh, deploy your software. That is the main crucial part as a software engineer. We have to verify our solutions to the users. Okay. Uh, so far, do you guys have any question regarding these things? Anything? Anyone? Okay. So let's move on to the this activity. So let's say we are developing a university attendance system. So uh, if you are interested, do it yourself. Uh, if we are developing it, we have to first identify the modules that university attendance system gonna have, because the first one is to use decomposition. When it comes to the big problem, we have to divide our big problem into the small sub problem. So when it's come to the university attendance system, we have to add student management, uh, lecturer management, course management, attendance records, reports, libraries, those kind of a component we have to include for our system. So we have to design those things to get a good system. And also we have to think about the main entities. So let's say we have a lecturer component and the student component. They are raw many to many relation with the same course, because the course is taught by the lecturer, the course is following by the student. So that kind of a relationship we have to identify those things in our side and add those things into our prompt. From that we can get a very good detailed code and explanation about what we are going to do. And then we have to work on a algorithmic way to implement one component. Let's say enrolling a student, we have to describe what we are going to do. Let's say we have a student management component, we have a lecturer management component, we have the course management component. So student have to enroll for multiple courses, and lecturers is uh, responsible for a group of students. So when the students is enrolling, we have to keep the student data in the course section, and we have to keep the student data in the lecturer section for the group. So that kind of a logics we have to add our prompt, and we can get a very good uh, generated code from the AI using this uh, computational thinking methods. So uh, please try this one yourself uh, and verify it. So let's do it your own, and let's do it with the AI help. So then you can compare those two softwares, and you can identify what is the lack of your knowledge, what is the lack of your thinking, and how to improve yourself to go into the modern software industry. So that is this active assist does. So do it yourself, and if you are having any kind of a question, you can ask me. uh, I will send my email to you guys, and you can reach out to me anytime. So do it yourself and try it out in different ways. So we are now coming into the end of this presentation. So now let's we talk about the ethics and responsibility in AI code. So we talk about what is computational thinking, and what is vibe coding, what are the component of computational thinking, what are the component of vibe coding, what is the use of vibe coding with computational thinking, and how we can improve our code to use that. So let's talk about the ethics. So when we are using the AI, we have to responsible for our code, because we are writing that code. We have to responsible what are the output, what are the input, uh, of the code. Now, in the current generation, people are very offensive about words because so therefore we have to be crucial about every word that you output from your code. From the AI, it can be generate insecure code and it can be lead into the accountability for failures. So our job is to identify those things and be responsible and fix that one as a human because software is very good if it has a touch of a human because uh, in naturally people are humans are like to work with human. So in the software aspect, if your software is acting like a human, users is very much like to use that kind of a software. So as an ethic, we have to concern about every little detail about your output. So that is the main responsibility that you have using these AI tools because AI can gives us a very offensive output. Let's say, as an example, I saw that in California, some a girl in 16 years old is suicide because of the AI saying that she's so dumb to use that kind of a thing in AI. So as a software engineers, we have to think about every little detail about your output in your code. Yeah. So this is the future of software engineering skill set in 2026 and going on. So as an engineer, you have to master computational thinking fundamentals. You have to know what will happen in the computer side, what does the computer processor is, what is processor's job, and what's the application, how the application is running, and how the optimization is happening, how the deployment is gonna do. All those basic understand you have to master all the basic understand of the concepts. That is a crucial skill that you have to have if you are going to be a software engineer in the future. And you have to be a good seeker for bugs. You have to be good at debugging and you have to be a testing mindset to implement a good software because we have to break our own code to get a better solution and we have to design a system that what is a future software engineer is going to do because the coding, the planning part, the task breaking down part, and all of these groundworks are done by AI now. So our job is to design the main high level architecture to build the software. That is how it's going to be. And you have to review your code very thoroughly. Not your code, the other code. The good practice is to use open source repositories. You can go to the GitHub and read any kind of a repository because those repositories are well reviewed. And let's say we are putting a pull request for an open source application, it get reviewed by at least 100 or 150 very skilled software engineers and it let's say we are pulling 10 lines of code, it get reduced to one line of code using that review comments. That kind of a review you have to improve your knowledge to get that kind of a review for your own. And also the very crucial part is working with AI. If you are not familiar with AI tools, if you are not using AI, if you keep track on the traditional path, you are not going to be an employer in the future because the industry is not expecting a traditional person. the industry is always looking for an updated person with AI collaborations and work with AI and how the AI is work. You have to have a good understanding about how the AI works, how the machine learning works, how to train a simple model, that kind of stuff. It is very good to have as a software engineer, and also security awareness. When it comes to software engineering, now software engineers is facing a big problems regarding these security issues because data is leaking everywhere and our password is not protected enough uh, from the new chipset that invented by I think I can't remember the company name, but there is a chipset now. It can be break SHA-256 encoding in 2 days. So now the and also two-factor authentications are now can be breakable. So that kind of a security level is achieved by this AI model and bot using bots. So we have to keep aware about our security of the system. So as a student, you have to gather all of these skills. I'm not saying that you have to be a master of all of things, but you have to have a brief understanding about all of these components like computational thinking, how the logic is happen, how to uh, break a big problem into the subcomponents, how to design a abstraction layer, interfaces, APIs, how to review your code, how to work with the AI tools, how to design a simple application, use AI to uh, create a documentation, those kind of stuff you have to be learn. And finally, AI can generate code but cannot replace your thinking. As a human, the machine cannot done thinking its own. I know AI is artificial intelligence, but it cannot be thinking its own. It's working on a trained dataset. So as a human, we have to improve our thinking ability for more logical and get a efficient output. And computational thinking is your competitive advantage. In current software engineering, uh, is expecting always thinkers, not just coders. So you have to improve your thinking abilities uh, along with this computational thinking, and also use AI tools as a highly motivated intern because AI is not get any tired or anything. It just gives us what we want. So we can use it as a highly motivated intern and use it to improve ourselves and learn new things and designing a new idea or in your day-to-day activities, use AI tools. So that what a future software engineer is going to be happen do because now in any field, let's say in medical or the software engineers is always use AI. In the medical field, in electrical engineers, in electronic engineers, in material engineers, chemical engineers is also using chatbots to do their designs as an engineer because it is very easy to develop an idea to use in uh, commercial base. And finally, I have to say this: don't just wipe code, just wipe think. You have to identify your vibe to think, how to use your thinking ability to find out the solution for a big problems and enjoy it uh, using these AI tools. Yeah. That is the end of my presentation. Do you guys have any questions? I can answer it now. Any question? If you are not uh, comfortable to talk, you can put it into the chat also. Any question?
Excuse me, Mr. Suwasana.
Yes.
Our participants has sent us questions through a Q&A platform. There
Okay.
are a few questions here. Can I read it out for you?
Yes, yes. Or you can just
Okay.
share the screen if you want.
Okay. So the first question is it okay to just know the vibe coding with the fundamental knowledge of coding, but not being an expert to join and start working in the industry?
Uh, it is a quite debatable because if you are using coding to yourself, let's say, if you want to have a lifestyle with uh, technical aspects, you can use just vibe coding and you find solution for your own problems and uh, you can implement your own softwares to your use or small kind of a use based applications. But when it's come to the higher level, let's say 1 to 2 thousand or 100,000 user base, you have to have a good understanding about the basic because the software is always going to break. Because of that, we have to have a good understanding about the core concepts. But you are using the coding aspect for your own problems. It's okay to have just know the vibe coding and implementing a software and use it for your day-to-day activities. It is okay, but when it's come to the industry, you have to uh, master the basics because uh, what is the usage of basic uh, understanding is mainly used for the debugging because if some uh, wrong answers is generated, we have to be responsible about the application. So that what the basic understanding is needed. Yeah. I hope you got an answer for your question.
So the next question is, could you recommend quality resources for learning vibe coding?
Uh, my recommend is to master vibe coding. There is no, I can't say this is good, this is bad, but the main thing to learn is do it yourself. You can access ChatGPT, Gemini, Claude, Anti-Gravity, and now these days are very popular, OpenClaw. Uh, you can do use all of these platform uh, and just start with a small idea. Let's say you want to make a smart home application. So just use the small idea how to switch on a light using our mobile phone, ask from the AI, and find out what is the software solution for that one. And obviously, you have to need hardware for that one also, but I'm just talking about the software part. So uh, when you are doing it your own, you face some problems and you are trying to find solution for that one. So that's how you are improving the computational thinking in the era of vibe coding. So as a beginner, nowadays you can use Gemini. Gemini has very good models to use for a vibe coding, and ChatGPT is very good. Claude is very good for the code generation. Those kind of a platform you can use. If you are willing to pay, you can use Claude. Also, it is very good for that kind of a vibe code. And now these days, very popular the anti-gravity IDE, because you can get a AI agent side your IDE with the open with your code base. So it can read your code base thoroughly, and it can identify what are the bugs. So you can easily wipe code using that anti-gravity IDE. You can use those platform. Yeah.
So the next question will be, can we trust an agentic AI model to build a full project if it can see our environment keys?
I'm sorry. Can you repeat that again?
Can we trust an agentic AI model to build a full project if it can see our environment keys?
No, you can't trust with the keys with your AI agent, because let's say the companies that provide the models and the AI agents, they are telling us to we are not providing those details to the outside source, but they are keeping those details themselves. So they are in their servers, so it can be available for any hackers now. Any servers can be hacked in any time, so it is not good practice to use your keys, your environment file, uh, those kind of stuff, not use in your AI bot. Use as a environment file. The anti-gravity software itself is not using the environment file for their one, it using local one. So we have to use the model in online, but it uses the local system to run the model and AI agents. So using that one is good, but when it's come to the development, don't use keys on that one. Keys you have to put in somewhere else, and to test it out, you have to use another IDE to run those applications. Yeah.
Okay. Does the industry allow vibe coding?
Yes, I'm also using this one because it is very efficient. Uh, it is uh, saving so much time, and we can work more stuff uh, to improve ourselves and as well as the software that we are built. It is okay to use vibe coding, but just don't depend on the vibe coding. Always think about you are the boss, you are the brain, and you are just using AI to implement your instructions. Yeah, that's what is happening in currently.
What will happen to the job market when the vibe coders start to overtake it?
Really good question. Actually, I don't have idea about that one also, because we have to look forward to that kind when it comes. So, as a prediction, we can say that most of the developing jobs and manual testing jobs, uh, BA, business analytics jobs, and even UI UX designing is going to replace with AI in some extent, but not all of them, but in some extent. Let's say if a company wants 3 UI UX engineers, but now we can go with the one UI UX engineers, because now there are tools available like Lovable to using AI to design your user interfaces with the UI UX. So the replacement is going to be happen, but as long as you keep your thinking is up and your brain is good to design yourself, and always you have to keep track on the new trends and technologies when we are enrolling this industry. We can't work with the old stuff. We have to keep updating day by day. That is the main thing about software engineering itself. Yeah.
Do we need know every programming concepts to code with AI?
Actually, the programming concept is quite same in every language. If you mastered one programming language, you can learn most of the fundamentals of the core concept in a programming language. Let's say the memory management, how the program is running, how the processor is used, how the thread is used. If you are using a Java, C Sharp, Rust, C, JavaScript, if you master one programming language, uh, you can identify those things. So if you have a clear idea about those basic things using one programming language, you can use any programming language to build anything. So the concept are same, because we all softwares running on a computer, so it's always accessing the same memory. So it not different with the programming language. Concept is same. It bit different when it comes to the scripting language and low level language. So my suggestion is, as a low level language, learn one language for the low level coding. As example, Java, C Sharp, or Rust. The new trend is go with Rust. And a scripting language, you can learn JavaScript. And as an interpreted language, you can learn Python. For using that kind of a structure, you can get a good understanding about the basic concept and also about the various concepts. Once you mastered those one programming language, you can learn any programming language in less time.
Can AI enhance our system security, or do we give it to do it without AI?
That is a very debatable question, because for now, AI can't guarantee the security for us now. So maybe in the future, with the available data, it can be done, but it's not good practice to keep all the responsibility to the AI. Still, I think people needs to hands on the security concerns with the help of AI. So it can be improve the AI knowledge with the time, but when it's come to the security, I think people have to involve uh, at least little. Yeah.
Yeah, that's it.
Okay.
So, do you guys have any questions? Feel free to ask anything.
आइए
Yes.
as a first year student of computer science, these days I am learning Python, and today I started C++. Is this the right way of using languages, or any other recommendations should I learn?
Molly, so when it's come to learning the programming language, are you interested with AI development? It is very good to learn Python in the first year student because it gonna use in the second year or third year. When it's come to the C++, uh, it it is a good language to learn in basics, but nowadays it's not used in industry. Some of the software are written in C++. In current day, they are also migrate to the Rust because of the memory issues. But as a student, it is good to learn C++ to identify how the computer is running the code. So from C++, you can identify memory management and how the memory is served, how the linked list is working, how the data structures are implemented. Those kind of stuff you can learn, and from that you can get a basic idea about the programming language concepts. If you are learning C++, learn until you familiar with uh, at least the memory allocation and performance based access and the thread allocations and mm, object oriented programming, and those basic needs you have to learn those things at least. From that you can easily learn any language within 1 or 2 weeks because you have the basic understanding about that language working on a computer. But you are just learning how to let's say uh, solving a hacker question or something. It is okay, but it's not giving you the basic understanding about how things work in the background. So you have to get inside the computer uh, how that things happen in computer. You have to learn those things as well. Uh, if you are planning those things as well, you are in the right track.
Thank you, Ais. One other question. Apart from learning those languages, is it good to have an idea about GitHub and other those things?
Yes, it is crucial to have a Git in as a skill because in the industry you have to work with the team, so we have to collaborate our code. And when it's come to the deploying also, we are using pipelines to continuous deploy, continuous integration. So it is a quite important tool to use GitHub. So you have to learn Git, not the GitHub, Git, the version management uh, in your software engineering journey. Yeah.
Thank you very much, Aya.
You're welcome. Mal. Okay, any questions? Yes, Ajay. Uh, silent means no question, right?
I think it's
Okay.
Questions. Yeah.
Okay. If you guys have any question, I'll drop my email to the host, and they will share with you guys, and you can drop an email for me asking any questions. Yeah. Over to you.
Thank you, Mr. Suvasanak. So, guys, could you please turn your camera as we are going to take a group photo now? Please cooperate, guys. Thank you, guys. So to wrap things up, a huge thank you goes to our Mr. Suwasana. So for sharing his expertise, and to everyone for joining us for this first workshop. It was a thought-provoking deep dive into computational thinking. It's clear that even in the white coding era, the fundamentals remain in our strongest tool. And to mention that, it was an interesting discussion, as I was also taking notes as well. So, guys, make sure to stay tuned to our WhatsApp group for updates on the next session in the first coming sessions. Thank you so much, Mr. Suwasana.
Thank you for having me.
Have a productive evening. Good night.
You too.